right, welcome everyone to the Global Passive House Showcase today. And I'm really excited that we'll be having Alan Gibson from Geologic present today about challenges and solutions in custom passive house panelization. I'm also really excited that we have Bev Craig to join us as host of the Global Passive House Showcase for the months of December, January, and February. It's super exciting to have Bev on board with us to do this. And many of you know her and her work, but I want to, for those of you who don't, I want to share a couple of tidbits with you all. She manages the Massachusetts Clean Energy Center's low and moderate income programs, including the Passive House Design Challenge for Affordable Housing, the Affordable Clean Residential Energy Program, and the Triple Decker Design Challenge. She comes from a background of energy efficiency retrofits and installing renewables at nonprofit Homeowners Rehab, Inc. And she holds a BA from the University of Southern California and a master's in public policy from Harvard's Kennedy School of Government. So with that, I'm very happy to hand it off to our host, Bev Craig.
Thanks, Zach. It's so great to be asked. I'm really, really honored, actually, to be hosting for the next 3 months. I found Passive House Accelerator maybe 2.5 months after the creation. And I don't know about you guys, but it was a sort of tough time then. I was really sick of working from home, even back then, and missed talking to people a lot. And to find this community, which is so welcoming to new people, so many mission-driven people, so many people so excited about their work and so frank about what is working and what is not working with the stuff that they're trying. It's just a great community, and I've really been happy to be part of it. And I hope if you're new that you feel welcome, and if you've been here a long time that you keep participating. So a quick toast. Some of you probably have libations or water or whatever, but a toast to community.
Hear, hear.
Hear, hear. And tonight, we're really excited to have Alan Gibson from GoLogic Prefab. You know, Sean's so happy, so. But I think I'll hand it over to Zach. We're gonna go to breakout rooms.
That's right, yeah, so we're gonna go into breakout rooms for about 5 minutes, and these will be 5 or 6 people probably. So you have a chance to do some rapid fire introductions to one another before we get started with the program. So I'll create those now and I'll see you in a few minutes. All right, everyone is back. So I hope that was fun, everybody. And I think, Bev, we're ready for you to introduce Alan.
So we're really excited to have Alan Gibson here. He's the manager of GoLogic, which is a 35-person firm in Belfast, Maine. They are a design build firm, general contractor, and a panel manufacturer. And Alan holds a BA from Brown University. He's also a certified passive house builder and designer. And GoLogic, their first Phius-certified home was way back in 2010. And Alan's really very involved with Phius. He's currently the secretary of the Phius Board of Directors and also the chair of the Phius Alliance. So thank you, Alan, for joining us.
Thank you very much. Do I share my screen now? All right, well, thank you all. Really excited to be here, excited for the Q&A at the end of my presentation. I'm gonna kind of blast through this pretty quickly. So this is just saying what Bev just said. We are a general contracting company, design build. We will general contract projects on the coast of Maine. We will deliver panelized shell packages throughout the Northeast, including New England and Eastern New York, and we could even go into New Jersey for the right project. And
it's going to be here soon.
Yeah.
Okay.
We have been panelizing in earnest for about 4 years. We're always learning. This presentation is, in my view, I've learned a lot from people who have been doing this for a while. I want to share information. I'm not hiding any secrets here. I really think panelization is the way the industry needs to go. So I'm very open source and open to questions. Bev also wanted to make sure I mentioned Panelized Retrofits, which I've been looking at for a while and excited about. I've been involved in one project, excited about those possibilities. So at Geologic, we've developed this line of homes called the go home. We also do custom work. The go homes come in lots of different shapes and sizes, all kind of in a design family. And we've panelized most of these. We let people, these are pre-designed homes, but we let people customize them, which is kind of to our detriment in a way. And we're sort of trying to steer people into doing designs that we've already done in the same way. And we're also developing designs that are, will have more strict rules, I would say, because partly for this reason, we are interested in panelization. We're doing custom panelization. There are other ways of doing it that are more standardized, but we're interested in panelization partly for this reason, what's on this slide, which shows that among all major industries, construction lags behind in terms of productivity, the amount of work produced per hour of work. And I think there's a lot we could talk about with this slide, but suffice it to say that the industry has been talking about going in the direction of some kind of industrial scale for building for a long time. And it's something that's motivating to us. So this presentation is going to be a little bit about how we do our panelization, and then we're going to show kind of a case study of a recent install project. So here's our crew in our shop looking at a presentation on Swedish panelization. I visited Sweden a few years ago with Scott Hedges, who is my Swedish construction mentor. He runs a website called Big House, BYGGHOUSE, where you can learn a lot more about Swedish panelization and look at some of the products they have on offer. And the Swedish system is quite well developed. About 80% of homes in Sweden are delivered panelized in a similar way that we do it and others. It's a very mature ecosystem. There are general contractors all over the country who are familiar with it, who install the panels that are made at true factories. They've been at it for, since the 1920s. And, there are a lot of reasons why it works there. Sweden's a more egalitarian society. They're used to the IKEA type delivery system. But there's lots of competition, lots of companies doing it. And they're producing basically passive house level homes with about half of the labor hours that we're taking to do homes. So it's pretty cool to see how it's done there. And, it'll be a while before we're there, I would say, but that's what we aspire to. I also want to say that I just want to acknowledge my crew, my company, for the work they've done to move our panelization process along. I kind of give them suggestions and ideas and projects to do, and they've really figured out, from the designers down to the guys here on the shop floor. And so just wanted to acknowledge that. And that's been really exciting about getting into panelization. So here's our little shop. It's not very automated or mechanized. It's basically, we're using some framing tables and some basic tools and some lifting equipment to build panels. One thing I wanted to talk about real quick is installing windows and panels, which I think is really important, especially passive house windows. There's a lot of value add that goes into how they're installed and treated in the wall. I get calls from architects who say, hey, can you, install these fancy European windows in our building because my builder doesn't know how to do it. And so we spend a lot of time, we have spent a lot of time figuring out how to install windows. Here's a session the crew did, a workshop basically on how to do it. We pre-assemble windows. This is a Swedish trick. You start out with a window and you put a buck around it. You flash it, you put trim on it. Here are some, they're upside down in this photo, but they're the first thing that goes on the table, and then we frame the wall around it. And there are a lot of advantages to that in terms of how labor is used. Real quickly, how our wall is assembled. This is a 2x8 or a 2x6 stud wall. This is the exterior we're looking at. We have the window pre-assembled in there. We put a sheathing layer on it. That's the airtight layer. Then we add 5.5 inches of wood fiber. And then it's not shown in this, but we will put a WRB on and then a strapping layer. And that's basically what we ship. And then siding is put on in the field. Here's what it looks like in real life. So on the left is the interior of the wall. That's the 2x8 stud wall. We've got gaskets on it, which creates the air seal between panels. Then we have the structural sheathing layer. And then we have the wood fiber. Then we have the vented strapping. And on this particular project, we have another layer of sheathing on the outside because it's getting cedar shingle siding. So there's a lot there. That's a complex assembly. There are a lot of ways to make an R50 wall to meet, this works well in our climate, zone 6. And, but, you know, I've done a lot of them and looked at a lot of them, and they all kind of take the same amount of work and effort. There's no real easy way of doing it. It is basically, as you can see, an all wood based product. So it's low carbon, which we used to use a lot more foam. We've shifted almost entirely away from that, and I'm really happy about that. So I'm going to get into talking about this project. Here is the site. This is Penobscot Bay in Maine, a beautiful little peninsula that was in the client's family for a long time. This was existing on the site, basically an uninsulated summer house that we removed and replaced it with a brand new passive house. So one of the big things, one of the big learning curves in panelization is to go from your architectural drawings to a 3D model and then to shop drawings. And this is something that we've taken on in the last year. So here are elevation drawings of this particular house. It's a 2-story, 2,000 square foot home. This is in Revit is what we use for design. And then we purchased CADWorks software, and it creates this beautiful 3D model that has every single thing in it that you are going to build. And if I had had this kind of tool for the 20 years I was a framing carpenter, it would have been wonderful. And I dreamed about it. You know, wouldn't it be great to have a drawing that showed where all the framing goes, so you don't have to figure it out when you roll the plans out on the deck and try to lay things out on your sticks of wood. This is an incredible tool, and it's pretty essential for doing any kind of, you know, modular prefab. And from that, you get a lot of 2D outputs. Here is a plan view of all the walls of this house. And from that, you get really detailed wall plans. Here's a framing plan shown in elevation, in section, and you'll notice every piece is numbered. And if we had a CNC saw, we could output the file to that, and it could cut every piece. And depending on how sophisticated you are, you could label everything. We haven't gone that far yet, but we cut everything by hand, and this is the actual cut list that's generated. And, you know, that's a lot of pieces. That's pretty complicated. And I think part of making this process more streamlined is to make this simpler. And there's another method of doing panels, which is in modular panels, where you may have a design, or you may have, you know, 24, 30 standard panels. And then it's more of a rote process, a manufacturing process of producing X number of number 4s, X number of number 8s. And I think that's something that will be part of our business moving forward as we develop that. All right, so here's one of the first days of this installation. We're on this site. The amazing thing is that all of these walls look exactly like the model. It's just amazing how that works. And one trick we learned from watching videos about how the Swedes do it is anything you can put inside the building at this stage, you try to do. So in the foreground, you see these pallets of windows, and those windows are too big to put into panels. And that's something you have to look at in your design. We don't do a lot of architect design projects because there are large walls of windows that you can't panelize, and you end up spending 10 times more time on site doing that. But in this case, we just have a few of them, and they dropped, well, rested softly on the slab. This pallet of windows that will be installed, it's right where they're going to go. It's going to be out of the weather as soon as this is closed in. The Swedes take it a couple steps further. They will actually put drywall, interior framing, and even mechanicals in with the crane since it's there, so you don't have to lug it in by hand later. Saves a ton of labor. So here you can see the model on the left, and in reality on the right. You'll have to rotate the model around 180 degrees in your mind to see it match up exactly, because the photo is not from the same vantage point. Here's a closer shot of it, a broader shot. Still a lot of standard carpentry stuff, bracing walls, straightening things after you set the panels in. So from there, we go to the second floor deck panels. And they're pretty simple, 8 feet wide by, these are about 30 feet long. They flat pack on the truck, and they get hoisted into place. There's the finished deck. Then we go to the second floor. And in this particular design, you can see how the second floor basically extrudes up from the main box extrudes up from the second floor. That's pretty straightforward. But we have this shed roof section that goes over the kitchen, and that's a little challenging spot that I want to talk about for a second, just as an example of what you have to think about ahead of time before you start building anything. You see on the left of this image the shed roof portion of the roof, and here's a section of that through there. And the tricky thing is how to get the air barrier to connect from the outside of the exterior wall on the first floor to the exterior wall on the second floor. And you can see the green line here is our sheathing that goes up the outside of the exterior wall, over top of the top plate, down to the top of this ceiling framing, and then up to the sheathing on the outside of the second floor walls. We have revised this section a number of times, but we've settled on this one. And the cool thing is that my structural engineer drew this. So we've been doing airtight buildings for so long that he actually puts our air barrier in his drawings, and that's pretty cool. So here's the site. Here's the panel coming in up to the second floor. Here's the second floor walls in place with the start of the attic deck. There's a full deck across the attic for essentially a third floor. And I want to show this because there are a lot of things related to the panel assembly that you have to learn. Rigging, crane signaling, safety, the order of operations is all really important. And we've, learned it kind of along the way. The site organization is important. This is a tight, narrow site, so you have to think about getting the mobile crane in there. We own our own truck and trailer, so we can transport panels as close as we need to. You've got your dumpster and your porta potty, you've got to fit in there, and a place to lay down the panels. So, it's another thing that's different about this type of delivery. Here's the second floor deck in place, and I love that there's a laptop there, which is in this system just as essential a tool as a nail gun or a level, along with the spray can, so you can write danger along the edge so people don't fall off. So the Rif system, there are different ways of doing this. We do a truss system typically, although we are developing a roof panel system for peaked roofs. And we could go into this later maybe, but here's another tricky spot where the air barrier has to be continuous from the outside of the exterior walls to the underside of the roof framing. And here's a section of that. So we use, in this case, the scissor truss up there, and the air barrier has to continue to the underside of that scissor truss. And we do it like this. So in green, again, the exterior sheathing comes up the outside of the wall, goes across the top plate, and then connects to, in this case, a membrane air barrier on the underside of the truss. We've done it a few different ways, but we've come to wrapping the profile of the truss with sheathing on the inside to make that connection. You can see it here. This gable end wall is sheathed. The profile of the truss is sheathed. There's insulation behind it. And there's a flap of tape there ready for the membrane that's going to come in later. Here it is on the other side with a little more detail. You can see that gable end panel was done in 2 pieces because we are at our height limit for the first one. And then the little triangle has to be built on top of it. And those pieces of sheathing are pre-cut and just tacked in place, ready for that little panel to be put on top. And then those pieces will get lifted up and attached. And you can see the tape on the lower side of them, ready for the trusses that are about to come in. Here's another challenge. I don't know why, but we always get sites with very narrow roads with tight trees on both sides, and no one ever wants to cut a tree, which is fine. But when the trusses come down the road on this truck, it can be challenging. And apparently this driver, I didn't see this, but the driver was using the trees to push the load around on the flatbed by going backwards and forwards so he could snake through this driveway. Here's a crew once the trusses are assembled. After this, it's a pretty standard, sheathe the roof, put the roof trim on process. Here is a view of the finished facade. Here's the interior, taking advantage of those views, those big windows. And this is not the same house, but I wanted to put this in to show you what a finished house looks like. This is another project that we finished recently. And that is it for the slides.
Wow, powers through it, and such a great slide deck, Alan. Thank you very much. Brilliant stuff. Like, there is a full deck here of questions. But first, Zach, over to you.
Thanks, Sean and Alan. Yeah, that's awesome. Really fantastic. So everything we do at the Passive House Accelerator comes thanks to generous support from our sponsors. So I want to take a moment to thank those sponsors. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingwe Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stocorp, and Zola Windows. Our champion sponsors are Icon Windows and Doors and SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our patron sponsors, Aero Aggregates, Aero Barrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Euroline Windows, Inotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood T-Stud. So thank you, sponsors.
Excellent. Thanks, Zach. All right. So Martin kicks off the questions. I put the list of questions in the chat there. So everyone get ready. And Martin, over to you for question number 1.
Yeah, thanks so much. And Alan, thanks for the presentation. We've actually been exchanging emails about a potential project at the Berkshires, and I still hope to come back to you on that. My question is the windows. In many of the models we see from builders, yourself and others, I always have the impression the windows are minuscule. They're small, tiny. And here in your presentation, you answered the question already. we see finally floor to ceiling windows, make use of the view and all that kind of good outdoor living and bring the outdoor inside. Is that something very super special, or is that something you're moving towards and can do, let's say, easily?
Well, it's something we've always done. So I think it's actually, I would reverse that question and say, you know, because it's basically impossible to install a large window that goes to the floor in a panel.
Yeah.
Do we want to continue doing that? It just takes so much more time to do that. I mean, it's a trade-off, right? And I'm always thinking about this in terms of architectural excitement and all of that good stuff. If it's not really conducive to panelization, therefore it's more expensive and takes more time. Yeah, we're going to continue doing that because we like that architecturally, but we have to everyone has to recognize that that's not an efficient way of building a house, right?
Yeah.
So there are these trade-offs, you know, and having a bunch of small punched openings is much easier to panelize, but you lose architectural value.
Right. Right. Okay. Thank you.
Sure.
Thanks, Martin, and thanks everyone for filling out the survey. It's great to figure out where everyone is and what you guys are up to. So thanks for doing that. Ben Larson, you had a couple questions because it's a a long list of questions. Give us one, and I'll put you back in the queue. Ben.
Yeah, I had a question on how you manufacture these things. Are you able to switch out building components such as the OSB for plywood or different types of insulation, that type of thing?
Yeah, we could certainly, that'd be an easy swap to go to plywood from OSB. We are currently, I was talking to Sean about this yesterday, you know, it's hard to get the wood fiber from Europe these days. We're actually looking at a different wall assembly that would swap that out for like an I-joist on the outside with a batt insulation, possibly hemp or cellulose batts. And so, yeah, you know, we're open to other ways of doing things, and we're, you know, because we're forced to, we have to look at changing things from time to time. Did that answer the question?
Yeah, sorry, Ben.
Adequately?
All right.
Yeah, I think so. Thank you.
All right, Ben, we'll put you back in the queue for other questions you had. Now, I think, Mark, you had a question that kind of might have been the same as Ben, but I know you have other questions, so I'll give you an opportunity to fire away at something.
The Ben question was perfect. So, Alan, for perspective wise, great staging, first and foremost, of the secondary processes that could be dropped in after the wall panels are in. So you could go from that. But for perspective, can you give us an idea of the different size panels that are made and the overall rationale as to why those sizes are chosen, both from your factory to the site stage of the setters?
Right, yeah, great question. So we're limited on height to about 10 feet or a little under, just for going down the road. We deliver the panels vertically with the windows in them. Now, some people I've heard of will ship panels flat with glass in them, which does not seem like a good idea to me. Maybe it can be done successfully. I wouldn't do it. And so that's a limitation on the height, which, you know, works out pretty well. We do a lot of taller first floors, you know, 9 feet. Sometimes we include the second floor rim joist in the first floor panel. So you have to take that into account. It's either got to be in the first floor or the second floor panel, because you don't want to fill in a strip in the middle, because that's just kind of wasteful. In terms of the length, my guys are really drawn to longer and longer panels. They like the idea of setting a whole wall in one panel. So you eliminate joints. It's only one set instead of two. That's one school of thought. I like that. It's also more efficient to build bigger panels if you have a table that can handle it, rather than building multiple panels. But there's a whole other school of thought, which is you build smaller panels. You have modular panels that are 1 foot, 2 foot, 3 foot, 5 foot, 8 foot, and you build them all on jigs, which requires a much smaller, assembly space, and you can do it, I think, I don't know, it's a debate if that's more efficient, but Adam Cohen, I've been talking to him for a long time. He developed Build Smart panels, and that system, I think for the right project like multifamily, where you're really just replicating a lot of panels, could be really efficient. So, the short answer is it can go different ways, but the way we're doing it in our particular designs, in our process, bigger panels seems to be working better.
That's a perfect answer. When I think of Legos, I always use the big blocks first. And then there's
Right.
a whole bunch of little ones just off to the side, but perfect answer. Thanks so much. Great work, Alan.
Thank you.
Yeah, Alan, that's an interesting question. And I appreciate the fact that you guys are using your own trailer. I know a lot of people are like, oh, well, I need to design panels based on all the other trailers out there in the world. And if you have 1 or 2 trailers at work, you've now created, up different heights that people like, because most people like a 10-foot height. And I mean, you can have a discussion in passive, oh, is an extra foot enough to heat? But sometimes it gives enough space that people want to heat it. And they're like, yeah, give me a 9-foot wall. And your system allows for that, which is fantastic. And then, yeah, the whole debate between small versus large, but if you've got a crane can lift it up. I know Build Smart goes to 8 feet because they can have 4 or 5 strong guys move those
Right.
walls and install them in place, but you now have less guys and you can be out in Timbuktu with a big crane and take care of things. So it's pretty
Well,
good stuff.
yeah, the Build Smart panels were made of foam and not as thick as ours. And I calculated like an 8-foot panel with a window in it, and our system is going to weigh like 800 pounds. So it's just not conducive for hand setting. But if you have a system that is, you can, I don't know, it's like how many more small blocks versus fewer big blocks, which is more efficient.
Fair point. I just assumed you had a whole bunch of Hulks working on your team, and that's it. Just pick everything up with one hand.
If you have that, no, I don't really. And too many injuries when you try to move too many heavy things.
That's exactly it. Okay, moving along over to John Weber from Portsmouth. John, you had a couple questions. Just give us one for now, and we'll get you back in after the long list here.
Sure thing. Alan, great presentation. That was awesome. It was awesome to see that picture of the first day, having all those walls up and all that stuff in there. That really speaks to the efficiency of it. And that's great. I just had a quick question on like the longevity of these houses. Have you had any problems with design that you've had to overcome? And like how long have you been building these? Have they withstood the test of time? Has there been any times that you've had to go back and fix a thing or two? Yeah, just that.
Yeah, we've never had to fix anything structural or significant to the house itself, and we've built well over 100 homes and over the last 10 years, and we've certified a half dozen of them, but we've built all the rest of them basically the same way. So the biggest callback we get are the fussy German windows, especially balcony doors that are a little bit too big for their little hinges, and we have to go and adjust them. And that's, we've learned to do that ourselves because there isn't a lot of tech support available unless you speak German, and I don't. But yeah, no, good. So far, knock on wood, we haven't had any major problems with anything we've built. We have we have a good structural engineer, and they sign off on every project, so we're not doing anything dumb. I had a conversation with a client who's talking to his GC in a project that we're just providing the shell package for, and he said, well, the GC says this thing is really over-engineered, but you won't have any problems. I'm like, and the owner said to me like, oh, so the standard thing is to not engineer it and then have problems. So, I love that question. Yeah, we put way too much rebar in our slab. Okay, well, how's your slab look? Well, it cracked a lot, but at least we didn't use all that rebar.
Thank you.
All right, John, I know you had another question. We'll come back to you. Now we're over to Hans, and then we'll get Adam next. So Hans, over to you.
Good, thanks. Hey, thanks, Alan, for the presentation.
That was fantastic. I'm glad to see somebody do the window trick from the Swedes, because I've always waited for that. I did notice though that your wall, it almost looked, you're using the OSB as your vapor control layer, correct?
Right. Yep.
And so it looked like it was in the middle of the wall.
It's in the middle of the wall.
Which in our climate doesn't really work. But,
yeah, what climate are you in?
Just north of you. Zone 5, I think, 7. Sorry.
Yeah, probably Jones. Yeah, it does. There is a point where we need to have a smaller stud wall and more exterior insulation.
Okay.
Or you could put you could put a class 1 vapor retarder on the inside if you wanted to.
Yeah. Okay.
Which would solve the problem.
Yeah, I guess so. Cool. Awesome. Thanks.
Thanks, Hans. Adam. And where did Adam go? Adam Kronk, where are you?
Can you hear me?
Oh, there we go. Yeah.
Okay. Sorry, I've been having camera issues, but I have some sound. Yeah, I actually had basically the same kind of question / concern as Hans. Just like from doing prefab with OSB in Ontario, and looking at some of the details, kind of scratching my head and wondering how would that model in Woofy? Like almost on the porch, the little detail with the parapet, where your structural engineer drew that in. I was looking at that and thinking, oh, I know in our climate that wouldn't model well. So I was just wondering if that had been specifically modeled. Because long-term moisture damage is something that really concerns me.
Right. In that case, that little shed roof area is vented. So, and we have, I mean, it wasn't clear in that drawing, we have 2 feet of cellulose on top of that OSB layer.
My concern was the top of the stud wall assembly where the double top plate was, where the air barrier, vapor barrier jogs upwards. Because that moisture will eventually drive into that space. It'll want to seek equilibrium, and the upper portion of that will be lower temperature. I'm skeptical of even asking these questions and getting too nitty gritty about the details, but it is something I had to deal with in the past, and just kind of wondering how it modeled for you guys.
Yeah, that's interesting. I don't know that we've ever done a Woofy model of that particular section. I know we did the wall back when we moved to this assembly, and it did just fine in Woofy. I think in that, where that stud wall goes up a little bit, I mean, it is all open below that with cellulose in there and no vapor barrier to the interior. So I would think that would dry just fine, or the moisture would dissipate through the cellulose.
Hey, Alan, can you pop up your slides? I've got a couple of people that want to look at this in more detail. And so for all of us that are, real passive house nerds, we're going deep real quick here. So hold on, that if we lost a few of you, but we just want to look at these details. That's why we have these events, is to, read these kinds of things. So Adam, are you talking about that?
No, it was back. It was what looked to be the porch, further back a bit.
There we go.
Right there, yeah,
right there. Yep.
So that causes me some concern, because on the left-hand side where it goes up to that double top plate,
yep,
that from a from an isotherm standpoint, in our climate, in any point in Ontario, we would definitely be into condensation in that portion of the assembly.
So yeah, Adam, it just depends with this assembly there. You are right, like it will face condensation. But if the assemblies around it have all the right materials so it can dry out, then it's not going to be an issue. So it might get wet in a couple of those weeks, but if it has a chance to dry out, then it shouldn't be an issue. But again, it's looking at things with the model. And I know, moving from Ontario to even to Northeast, just that climate zones could be different. So there's, again, it's a very great question. And this is what's nice about what we do is we can model that and figure out through WFI, how that'll work over time. And, and so like you've got good insulation on both sides. It's really that top plate that is getting, cold in the wintertime. And so how does that play out from a condensation standpoint? It'd be interesting to see.
Yeah. And having the software, it's always wonderful. Like all these tools that we get to play with are so cool. And what works in one place doesn't work in another. And it's cool to just know what people are doing.
Yeah. And Ben put a comment here. Yeah. So the interesting part is managing bulk water versus vapor. And of course, yeah, we don't want bulk water getting into any of our envelopes. And so that's the question is always, will the bulk water sit on the top and potentially dry out, or will it get in the cavity? But again, this is why we model those kind of details and figure it out. So.
Yep.
Yeah.
All right.
That's
So
a good question.
We're going to go from the nitty gritty back to the upper part. And thanks, Adam, for that great question. And
I wasn't trying to stir a pot. I just wondered.
No, not at all. No, I'm not taking. I mean, this is why we have these discussions, is to look at, because there's different opportunities of how you can build and construct. And this is why we have this. And as Alan said at the very beginning, he's here to collaborate and help the industry change. And I mean, even in his market, he needs like 90 other factories to compete with better housing stock. So you know what, everyone giddy up and copy Alan, because there's more factories needed, and he's already leading the way. So give him some credit and buy him a beer next time you see him and get it going. So over to the next list, and Shushruta is up. I had a question. Shushruta, I'm going to find your question. But yeah, if you want to come on and ask it, go ahead.
Sure, thanks, Sean. My question was, with the new prescriptive path coming out for passive house, do you see that as a certification method that's viable with the Go homes? Or like, if you're thinking about it, what are the challenges that you might face with that?
Yeah, good question. I really don't know too many of the details of that. I have heard there are some challenges, and I think we'd run into it, for instance, in some of our designs where we have the really big windows, because I think the prescriptive path kind of limits what you can do there, even though your overall energy balance might be just fine. So yeah, I'm not really qualified. There are probably other people here that know more about it than I do, but yeah, I think it's a great way to go with it. Certainly simplifies the process, but I know there are some limitations because it's more of a one size fits all solution. So I think it's really much more design dependent about whether it's going to work for you or not.
Yeah, thank you. I was going to say, yeah, you'd have to have much smaller windows.
Yeah. So, we would probably go the more conventional certification route typically. But, we also want to design some projects that are simpler that might fall into that, and be less expensive to build. So that may be the way we go for certain of our models.
Great stuff. Thanks for that question. I'm going to have one more before we turn over to Zach. So Bruce, heading over to Milwaukee. Bruce, hold on, you got to unmute. There we go.
The question I had was regarding the wood fiber insulation and which one you were using. Obviously, it's getting harder and harder to obtain it, but here in the Midwest, they don't even know about it.
Yeah, and like I said, we're going to be moving away from it just because of the increase in price in shipping, and there's apparently a big demand for it in Europe. And Sean was saying that France just passed a law saying you have to have low carbon insulation, and that's created a big demand. So they're building more plants there. Anyway, we've been getting it from Styco, where it's manufactured in Poland, and we got a really sweet deal from them about a year ago, and that deal has slowly eroded until it's just not cost effective anymore.
Do we have no industrialists in this country anymore?
Well,
Welcome. The
good.
opportunity.
Glad you should
Good
mention
segue.
that. There was a spin-off company from GoLogic called GoLab. And if you want to look up GoLab there, I'm not involved in that now, but there's a plan and a mill and financing in place almost to build a wood fiber manufacturing plant in Maine that will do bat and blown in and board, the exact same products. And they're about 1.5 years away from rolling it out onto the market. So
Glad to hear that.
yeah.
Yeah, Timber HP. I'm just trying to think of there's someone that had a virtual tour of it last week that I saw some photos of it, and exciting. Again, they're working on it.
Yeah.
All right,
That'd be
Alan,
great.
you take a break for a second. We still have a lot of questions in the queue here. Thanks everyone for the questions, but we're gonna head over to Zach. So Zach.
Yeah, thank you. Yeah, we have some cool events coming up and also some great stuff on the podcast right now. So the current episode of the Passive House podcast is an interview with Matthew Cutler Welsh, the co-host of the podcast, that he conducted with Joseph Life, who is a CPHC and an architect in Auckland, New Zealand. He's with Respond Architects. The conversation, though, is all about the house that Joseph designed and built for his family, this passive house. It's actually a follow-up to a first interview that Matthew had on his other podcast, Homestyle Green. So if you go to the podcast listing on our website and you access this episode, you'll also be able to find a link to the original. But it's really interesting to hear about, designers' perspectives and plans about 1 year ago from that first one, and then what it's like to be in the house now. And really, really cool and a very unique design as well. So pretty great stuff. We're also still rolling out bonus episodes from our time at the Phius conference in Tarrytown, New York. So Ilka Cassidy of Holstrom System, and also a frequent guest co-host of the Passive House podcast, is the most recent interview. These are shorter, like 10 to 20 minute interviews that I had the chance to do at the conference. So please check those out on the podcast as well. Tomorrow, we're really excited. We were just talking about manufacturing facilities in New England. Well, Glavel has opened their factory in Vermont. And so we're going to get a tour tomorrow, a virtual tour of their facility, and also dive into foam glass solutions for Passive House. So this is going to be a conversation with Rob Comboy of Glavel, Passive House Component Spotlight, tomorrow at 10 a.m. Pacific and 1 p.m. Eastern. I will include a link to this in the chat, but we're getting good signups, and we hope that you'll join us as well. It should be really fun, and you can ask any question you have for Rob during the Q&A session as well. So you'll get that interaction. Next week on Construction Tech Tuesday, we are joined by the wonderful Sai Safi of Uber Green Space and Homes. And Sai will be presenting Uber Great, and this is with a PH, so I'm not swearing, fuck ups, at Louisville, Kentucky commercial passive house. Sai is just a really inspirational practitioner and has been doing some really great work in Kentucky. So please join us next Tuesday for Construction Tech. Then on Wednesday for the Global Passive House Showcase, we are joined by none other than Bronwyn Berry of the Passive House Network Board, and also the principal of Passive House BB, her own architecture firm. She does all Passive House work at that firm. And so she's going to be talking about how to transition to a Passive House practice. So she'll be kind of sharing her process for moving in that direction and bringing clients along in that journey. So really great kind of lessons and pointers for doing that in your own practice. And then on Thursday, we have episode 3 of this 8-part mini-series that we're doing, this Zoom series, the Building Performance Interactive. And this is an Ireland and UK-based show that we do at 9 a.m. Eastern Time, which is 2 p.m. in Ireland and the UK. So it's 6 a.m. on the Pacific coast. So we'll be joined by Dara McGowan, Mike Jacob, and Ben Adam Smith, the co-hosts. And we will hear from Andrew Simmons of Simmons Mill Architects and Tim Hulse of EcoVert Solutions about waterproof, breathable fabrics in low carbon Enerfits at scale. So please join us. It's really fun to have kind of this, to be building community across the Atlantic. And so if you're curious about what's going on over there and keen on making connections with practitioners over there as well, don't miss it. I think that's it. Okay, I'm done. Thanks.
All right, over to Bev for some final words, and then we'll turn it over to the after hour. Bev? Oh, Bev snuck out for a second, so I can see, though, she's still got the Christmas lights on. We'll come back to her in a second. Thanks, everyone, for joining us. The first hour has wrapped up, so thank you for joining us on the showcase. I'll get Bev to put in some parting words when she's back in her control center. A lot of great events lined up next week, and I hope that you'll stick around for tomorrow. I do know that we are going to get a virtual tour, so if you want to see what this factory is going to be doing, this is going to be fantastic. So join us for tomorrow. I still have a lots in the questions, and before I get back to the question queue, Edie Dillman from B Public Prefab has some exciting news that I wanted to share. She might not want to hop on here because she's sometimes shy, but she just got awarded to be able to build 5 passive house light with the Habitat for Humanity in Santa Fe. So the fact that we're going to see more of these exciting projects in her backyard with all of her efforts. I know these things take a long time to come out. So Edie, from all of us, great for what you do for the community. Bravo for that exciting news today. I'm glad to share it tonight because it definitely put a smile on my face when I read it this morning. So congrats to everyone in your team and everyone that you work with. I know it wasn't just all of your solid efforts, it was more, but I just wanted to give you kudos for what you're up to. So I'll have to find out the announcement, but I'm sure it'll probably be on their website, if not soon. But congrats, Edie, and the rest of the B Public team. Now we're going to move back into questions. I got like 8 on deck here, and I think there's a couple more that just came in here. So we're going to head to Jean. Jean, over to you. I'm just going to make sure now people haven't left it. Oh, Jean, you're there. There you are. Perfect.
I just wondered if the second floor deck was a panelized system or built in place.
It is panelized. Yep. The goal of our crew is to reduce the time on site as much as possible. We want to get it down to a week for a house that size. I think they're at about 9-10 days now. So yep, panelizing those floors, and we're going to get into panelizing all the roof panels as well.
So Jean, just so you like different language, those are called floor cassettes. The Germans call them elements. A couple of people call them cassettes. Some people might call them panels as well. So, you know, they are a prefabricated floor system that just makes it easy to stack, because those ones are easy when they get on the truck. It's the walls that take up the big space. So, and okay, Patricia had a couple. Patricia, I'm not sure if you're having issues with. Oh, you are here. Great. Go ahead. You can go ahead and ask both your questions.
Can you hear me?
Yep. Go ahead.
I'll just ask one because the other was about the insulation and water thing for the walls, but you did have a section towards the end of the building that showed the foundation. And I wondered if you could tell us anything about that foundation and the insulation. I didn't see a detail of that, but I wouldn't have expected it because I know you're doing the wood part, but I just wondered. I just also want to say I still live in Camden, and my sister lives in Port Clyde, near Port Clyde. So next time I'm up that way, I'm so glad to hear there's so much going on there. I had no idea. So good job.
Yeah, nice. Thanks. While I like the idea of panelized foundation systems, there are some. We're going to actually do one on a project, prefab foundation walls. But in this case, on this particular project, it was pretty conventional frost wall with a slab. And we have 6 inches of EPS on the outside all the way around. And that kind of lines up with the wood fiber on the wall. And then we have 6 inches under the slab. So super insulated foundation.
It looks like there was a line above the slab. Was it like what is the flooring above the slab?
In this case, it's just going to be the concrete the finished floor will be concrete, but we have done a lot of flooring on top of concrete. That's totally fine too.
And who is your structural engineer, if I may ask?
It's Albert Putnam and
Putnam?
Associates. Putnam.
That guy just got
Albert
hired
Putnam.
by everyone who's on here tonight because,
Yeah.
as you said, as he includes the air barrier, that guy is a star.
Well, maybe I shouldn't say that because they're really busy and we don't want them to ditch us.
Well, just make sure that there's a reference check that comes back to you after these other clients come on. Too, so.
See if
Thank you.
that happens.
Thank you, Ellen. I hope to meet you.
Yeah, likewise.
Thanks, Patricia. Always great questions. Just before we go to Scott, I've had a request of Sean, how did you turn your Christmas lights on? And I will show you and tell you how. Again, I don't know if others have their trees up and your lights on, but what we do on Zoom is where you have the stop video button, you can click on the little upper arrow there and get into your video filters. And in video filters, on about the third line down, it's a little blue box that has lights. You can add Christmas lights to your feature tonight too. So again, we're trying to get into the holiday spirit, trying to have more fun. So if you had any questions, just pin me and I'll kind of work through it. But that's the idea: is video filters, third line down, there's the lights, and you can have fun like with us too. Bev, and you got taken away by either dinner or something, and so we didn't get to hear your final words in the first hour. Do you want to just provide any feedback or anything that you learned or other things that are going on in your world, and then we'll get back to questions.
Yeah, well, this is really exciting stuff. I think I can't wait to see what Alan comes up with on retrofit panels, because our existing buildings and retrofitting them is our biggest challenge. It's a big mission, but I think Alan's up to it. So thanks everybody for joining. And sorry, I went to go grab something to eat.
No worries, man. It's okay. I guess, we might have all heard the hunger growls from through the Zoom. So we knew you needed to go. So thanks for that. All right, Alan, still got a bunch more questions. So again, let me know when you need to leave. We'll keep firing at them. Bev has turned into a bear, so she's in her happy place. Scott, over to you.
Hey, Alan, it's good to see you. Thank you so much for this presentation. I had been looking forward to this ever since I saw that you were going to be doing this. This is awesome. So yeah, a couple quick questions. Moving the windows vertically in the walls seems like a no-brainer for us as well. But I'm just curious if you've had any problems with breakage, or do you take certain medications for it to keep them from getting broken up?
Well, I don't know if you could see in any of those shots, but we do put pieces of OSB over them on the outside.
That's what I figured, yeah.
We tend to stack the panels so that let's see, how do they do it? They put them face to face on the racks that go on the truck, so that the protected side is on the outboard side. I mean, you want to worry about like a rock coming off the road and hitting the glass. You definitely want to cover with something solid out there. Then on the other side, on the inside, we usually put just strips of house strap, tie-par, staple it on, so you don't get, somebody just swinging a level and hitting the glass.
Makes sense.
So, yeah.
But the vibrations of the truck and stuff like that, do you put it on foam panels or pads or anything? It just seems fine.
It's just fine. Yeah. I mean, we have been installing our windows with gaskets actually. So there is a little cushion there. That might be a little factor, but however you do it, maybe you're going to have like a sealant between your window and your buck, and that would probably help cushion a little bit. I mean, they've come in a container across the ocean, on a truck to the port, on a container across the ocean, and then on a truck. They're able to handle that.
That's what I figure. Okay.
Yeah.
The second little part of that was just, again, trucking. So you've got one or two trailers, it sounds like, and then you can't take like the whole project that way on just a couple of trailers, right?
No.
So I guess how many trailers does it take for a typical size project? I'm guessing like 3,000 square feet. And do you just hire truckers to move your trailers? And just curious about the logistics of that.
Yeah, great questions. Things that we've all done a lot of different ways over the years. We hire trucking companies sometimes with big tractor trailers, and that moves the most panels in the most efficient way when we're going the farthest distance. But you're limited on the other end. Can that truck and trailer get down the driveway? Or do you have to, I mean, we've done a lot of panel ferrying where we have a telehandler at the end of the driveway and it's lifting off 2 panels at a time and walking them down a long driveway to set them on the staging area. That takes a lot of time and a lot of rigging and a lot of hassle. So we have found, we bought like a Ford F-350 and this gooseneck trailer with, you know, the 5th wheel thing. And that can take maybe 4 to 6 panels. And we may have, you know, 30 panels on a job. So we use that for more local, you know, an hour or 2 away. It wouldn't make sense to do that for, you know, 4 to 6 hour trips. So, you know, you got to figure that out. If you can get the big truck and trailer to haul it close, and then maybe you have to do a transfer, that's one way to do it. But it's been really, and one of my guys had to get a CDL license so he could drive it.
That's my other question. Yeah.
Oh yeah. And then if you want to take a truck, if you want to be a truck, like go out of state, it's a whole other like horrible bureaucracy that you just don't want to do. So that's something we kind of went down that road and then had to give up.
Gotcha. Thank you so much, and thanks for all of the help in the past too. We're close to our facility here in Portland, and I've got a packet of stuff to send your way soon. So
yeah, that's awesome.
Thanks so much.
Yeah, it's been great to talk to you about it, and I'm really looking forward to seeing where you're at and what you're doing.
Cool. All right, take care.
Great stuff, Scott. Yeah, I'm going to save my logistic question to the end because I think that's playing more a part that sometimes people don't fully know about when it comes to prefab. So Alan, is Alan still here? Just check on Alan. Alan Lehman, you're up next in the queue, but I don't see where you're at. So if not, let me ask Alan's question. Let me go find it for you because we all want to know. Alan, where did I bury it? Right, Alan, you're gonna have to hold on. Alan, we're gonna skip you for a second and go to Paul Thompson. Paul, I know you're there.
I'm here.
There you are. So I can see your other teammate there too.
Right.
So it's great. Over to you, Paul.
On my screen, she's right next to me, and in real life, she's right next to me too. So Alan, this is great presentation. We happen to be working on a couple of panelized passive houses, and so it's nice to see. We're working with Ilka on using their system, and I was particularly interested in you've talked about efficiency a lot, and you mentioned that you don't have a CNC router or a CNC machine, which in my view means not you're supporting local craftsmen and craftswomen that are making these passive houses, which I think is a great thing. When you think of factory made, you think that there's great big machines and computers that are making things. I think it's cool that you have people doing it. Is that a financial decision, or is that a practical decision based on where your company is at this point? And where do you see the future for how you're going to get these panels put together?
Right. Yeah. Great question. I mean, basically, the answer is it doesn't work financially for where our company is now. Everything we've done to date has been just finance as we go. I am going to make a big investment in a new building because the current place we're in is just too small. And I'm going to get some fancy equipment, basically a big honking forklift, an overhead gantry, and what's my other big piece of equipment? Tables, folding tables, so we can work on both sides of a panel at once. But to get to the next level of like the CNC and the automation and the nailing bridges and all that kind of, now we're talking millions and millions. And there's just, that's blueprint robotics. And, if they can make it work, great. Or that's Katera with giant amounts of money that failed miserably. I don't want to be that guy. I'm not going to be that guy. And I can't come up with that capital anyway. So, it's a really good question for someone like a GC who wants to move into panelization, like Scott Kosmecki. It'd be a good question for you. What's the appropriate amount of investment? Are there is there financing available? How do you make that move? Because it takes some capital to do it. And I think it's foolish to look at it as, and a lot of people do this, they look at all these fancy machines and we've got to automate the whole thing, and it just doesn't make sense. And you can, you've got to feed that process so much. And what happened to Katera, like they just didn't have the business plan to get the projects out the door, right? They could have produced 10 times more than they did, but they didn't understand that every project has its own entitlement on its own site and its own process for making it happen. Anyway, that's a good enough answer. It's like eventually, possibly, I'd get into more mechanization, but only after a few years of being profitable.
Yeah. The other quick question was, I just, when you're looking at some of those photos that you're showing towards the end, like there's a lot of wood, is there a way to reduce the amount of materials that we use to make buildings? And is panelization a way to do that? Is sort of a conceptual project? And then, of course, I'm really interested in how do you do renovations with panels? I'm looking forward to seeing that show.
Yeah, it is a good question. I mean, optimal value engineering for wood framing has been around for a long time, and I don't want to go into that. We do some of that. In some ways, panelization can use more wood, especially if you use small block panels, because you have a stud on either side that you're meeting up with a stud on either side of a panel. And if you have a lot of joints, that's a lot more wood. That's partly why I'm a little skeptical of that system. But yeah, there are definitely places where if you were stick framing it on site, you could probably save a piece of wood or two here or there. But there are probably opportunities for reducing the amount of wood if you really engineer it properly. So we don't focus on that a lot. I don't see that as a major problem. And now that people want to sequester carbon in wood, it's not mass timber, which has its limitations, but in some ways, the more wood, the better. What was the second part of your question? Sorry. Retrofits. Yeah, there are a lot of people. I've been studying this for a while now, and there are a few people, successful projects in Canada that I've looked at a lot. It's a whole different kind of ball game, but in panel design anyway. But it's the energy sprung concept. You just if you're familiar with that, sure, wrap the whole building in panels and put the mechanicals on there and the solar panels, and voila.
Yeah.
Which takes a really zero home.
It takes really sophisticated, scanning, and now you get really into the cutting edge of making things and farther away from craftsmanship, or at least hand craftsmanship.
Well, yeah, people worry about that, and I know there are a lot of traditional carpenters who say I'll never work in a factory. I get that, and I don't think the craft part of building is going to go away anytime soon. I'm not really worried about that. But there is still a lot of carpentry that goes on inside a panel factory. I mean, you have to, use a lot of experienced tricks of the trade to know how to put a panel together efficiently and accurately. So it's not like, the panel factories of the future are going to be, populated by automatons who do. It's not like a car factory where you're just like screwing one thing on. There's a lot of different steps you take that you have to do with traditional carpentry skills.
Okay. Thanks, Alan.
So many good points, Alan. And so I got to say a couple. Paul, you mentioned retrofits. I actually saw Alan give a similar presentation on the Babina Institute's their Reframed program that Betsy's doing. And so Betsy was doing meetings every 2 weeks to kind of move that along and make sure we're all kind of intro. So if you're interested in the retrofit side of buildings, please check that out. She's really trying hard to get all the right minds in the right place to figure that out. And Alan does have a pretty cool panel. And you know, on that point, it's if the structure's still there and the structure's worked for 100+ years, you just need to apply our lovely principles, right? Put on the sweater, put on the air barrier, and make it. And I mean, it's great that the Energy Sprong has a cool model. Unfortunately, North America, we don't have these row helms that are like in the hundreds. So we've got these complex boxes, and the gentleman that Alan was referring to is Butterwick Construction in Edmonton. They did kind of like the first sweater detail in Edmonton, and it was a challenge. So it's coming. Other thing that was mentioned is one thing that Alan has done really well, that if you're ever looking into prefab, is you start your factory with a really good software package, and then it helps a lot of those issues. So CADWorks, if you're interested, check it out. There are some other ones, Dietrix and some other software, but most of the prefab companies that I deal with use CADWorks. And then after that, it's all about saws and tables and overhead cranes. But we can have a whole separate conversation of that, because I've definitely designed a few factories. And last part I said is, if you are going to check out Pembina's Reframe Initiative, you also need to read the Passive House magazine, which Mary did an amazing job with all of the retrofits. And this is, you know, a bit going back a few months, but you got to check out that magazine. There's lots of great articles that Mary's put in there. So check that out. So anyhow, Paul, you brought up a lot of good things. I just had to tip on a few of those because, as I said from the beginning, I knew I was going to love this show because it's just right in my wheelhouse, and Alan is one of the leaders in it. So it's just great stuff. Because Alan Lehman had a question, and his was, you know, what would it cost, or if I was going to set up a small production of one house at a time, what would the minimum size shop look like? And I would almost say, Alan, just look at what Alan did, because he's doing a few more. And pretty quickly, Alan, if you were Alan Lehman, sorry, he's directing to, is if you're looking for different shops, you know, again, it's pretty easy to go on Instagram or, you know, in the web and see what people have to start up their shops. You'd be surprised of what they pump out of a small space. So, but the software is your biggest bang for your buck to kick off a prefab factory. So, all right, sorry, Alan, got on my soapbox. The next person in line is John Weber. You had, I put you back in the queue. Did you have more questions for Alan?
I know I had a funny comment about the truck driver, if a skilled driver is in the specs of the house or not. But no, I actually do have a question. What is the lead time on one of these houses right now?
Good question. I mean, we're pretty much booked up for 2022 right now. But if we get through the design process and we sign a construction contract, then we order the windows. And right now the windows we're getting from Germany have like a 5 to 6 month lead time. So we don't build anything until we get them, the windows, because they're incorporated right into the panel. So that's 6 months. And then it takes us, you know, 4 to 6 weeks to put the panels together and another week or so to install them. So, you know, we're looking at 7, 8 months from signing a construction contract.
Cool.
Yeah. Yeah, I mean, I'd like to reduce that time frame. Obviously, having that long a lead time for your windows means you have to do a lot of advanced planning. And there are other ways of doing it. I mean, and I don't know if Edie, I know you're doing the modular panel system, and I don't know if you're pre-ordering windows, but if we can work a deal with the manufacturer wherever to they have windows in stock and we have windows in stock, and we just pull from our own inventory, then we could reduce the lead time tremendously, which I'd like to get to if we did fewer custom projects and more standardized projects. Then we'd do that, and that could really cut the lead time down.
Yeah, we'd love to do windows with you, Alan. Anything. Partnership and doing it together really is, you know, I love this group, and it all should be in collaboration. We should all be thinking that way. So really sweet.
Absolutely. Yeah. Still looking for the wood aluminum clad window manufacturer in the North America who can do the German level of performance, but for the same price. Not quite there that I found. A few PVC options, but.
Yeah, Alan, I know Veta Windows here in Canada is a really good price point when it comes to wood aluminum cladding. I know they're looking at providing windows in the US. I know, again, 475 has OptiWin, and you know, it has a little bit more options, and that makes it a bit more pricey. But to me, you know, from those two brands are what I talk about here in BC all the time. 475 doesn't have the rights here in BC, but I always mention it to people because they're just such a nice solution. There's a lot more people chiming in about other American solutions too, so we'll keep those going too. Thanks, Edie, for coming in. And again, now that we get to see your face, congrats on your lovely news. Again, just such good news, you know? We worked hard for this stuff, so bravo. Thanks for joining us. Eric Ream, where are you, Eric? There you are. Just hit the unmute button. You had a question. Thanks for your patience.
Oh, I did. This was just a general question, not related really to the presentation, although certainly motivated by that. As I wondered, there was some concern raised about Styco during the talk following the presentation, and I wondered, are they, other than slight differences in R values per inch, are they essentially interchangeable? And secondly, is there a price advantage over one than the other? I figure those of you who are buying and
Alan,
selling,
should I answer this question?
might know.
Styco versus Gutex, you mean?
Yeah.
Yeah, go ahead, Sean.
So the difference mainly is, Eric, is the Gutex is a dry manufactured process and the other ones are a wet process. So just in that means that if you're looking at the carbon footprint in one factory to another, the Gutex is 40% less energy required. Both are wood fiber, both are great. And the biggest issue as we're currently having again is the European demand is increasing because they want to have more carbon friendly insulation, and they're adding more insulation to their walls, which making it difficult to get over here. But typically we have Reed Rollins who's on. He's in Washington DC. He's connected, I think, to Styco, and we've had a couple other people that are that come on that are involved. And there's other brands too, but the lead times right now are 3 months to 6 months, and with container prices, it's really pushing that particular product as a luxury item, and it's unfortunate because we all want it. Timber HP can't crank up their factories soon enough because we'd all we see a lot of trees here in North America, and we're like, why don't we have this? And unfortunately, a lot of these big factories are happy producing 2x4s and 2x6s and not, they don't want to look at the value added products like mass timber or wood fiber insulation. So I'm trying. If there's
Hey, a quick follow-up question. Are EPDs, environmental product declarations, available for both of those products that would verify the embodied energy claim?
Yeah, you should be able to find it.
Okay, and am I allowed to ask if there's a price difference between the two?
Yeah, the Gutex, well, it kind of depends now on which brokerage you're talking to, because the shipping prices have increased so much that that's a bit of an issue. But there will be a slight difference, anywhere between 5 or 10%, depending on which sales guy you talk to. And again, you're also looking at the different quality of products, and so there's always that value proposition between the two of them.
But wood fiber for quantities. I mean, it's you probably do a quantity discount too, and how many can you take at a time on what size truck? And
Eric, the best way to ask the question is, how much wood fiber at what thickness can you fill in a container? Because if you just ask for what you need, you're really talking about oranges and apples. You really want to be like, how much? Because honestly, once you get it here, if you have extras, you could sell it on the black market pretty good. So get your hands on it and get it here, and there'll be people that want to buy it. So
okay, Gutex crack. Okay.
Hey, someone's going to start it. Might as well be you.
Indeed. Thanks.
No
Appreciate your candid answers.
Well, again, I have a bit of an insight on why I'm trying to promote it. So Sai, over to you. Thanks for your patience, and we're looking forward to next week. Go ahead, ask your question.
Thanks, Sean. Hey, Alan, it's always great to see you, man, and always see you at the conferences and chop it up with you. Awesome work. Absolutely beautiful. I was wondering about the buck that you do prior to installing in the wall. Do you use any shims around that at all, or are you going with that gasket directly with the wood and then fastening it from the inside to that buck?
Yeah, we've gone around a few times on this. For a while, we were attaching that buck directly to the window, but I don't like that because it gives you absolutely no adjustment capability in the field. And you're relying on your, squaring and reference lines on the panel on the table to make sure that window is plumb and square. So what we've been doing lately is leaving a gap around the window with a gasket. And the gasket is the air seal, and it gives you like a 1/4 inch all the way around so that you can adjust those screws when you get the wall stood up and you check the operation of the window. So I like that much more. You could do shims and you could put in some sealant in there, which would do the same thing. Awesome. Or you could tape them in. You can use screws that give you adjustment capability too.
Is it a window that you're using with the clips on them? Is that what you're saying?
No, typically screwing right through the frame. So you take the sash out, you put the frame in, you install that, and then when the panel is stood up and going out the door or out the door is when we put the sash in.
Got it. Thank you.
Sure.
Can I quickly just add on to that and just ask, are you using like when you say a gasket, Alan, do you mean like the Hana tape or one of those expanding tape things?
No, but I think that is a good idea too. I think that could be a better way to go. We haven't tried those. I haven't tried those recently. No, it's more of like a bulb gasket. And it also takes, where it goes around the corner, it's not a perfect seal there. So you do have to put some goop in the corners. Yep.
Sorry, everyone, I got carried away with some comments in the chat.
No problem.
Didn't even hear the answer, so hopefully I'll have to watch this in the replay. Sorry, Sai. Kofi, got your answer. And I think that is it for questions. I think we got through the list. Is everyone happy? Did I miss anybody? I did. Put up a hand.
Quick question, more about supply chain kind of stuff, Alan. Like, I'm a little concerned. So I run with the Carbon Leadership Forum people, and embodied carbon is so important. Everyone's telling everyone to use wood fiber, and if the only plant we can get in the Northeast is still 1.5 years away, and we can't get Gutex anymore, like I'm worried. It's the same thing with mass timber, right? Like here, I mean, everything I can think of doing besides getting reclaimed XPS out of demo projects, like I don't know, like what do we do?
There's always cellulose, perfectly good option. And we're looking at a hemp bat product right now, which I think is interesting. There are also cellulose bats. I mean, there are lots of ways to do it without resorting to petrochemical insulation.
And Bev, just too, is Gutex is setting up a new factory. It'll be hopefully live by early 2023. I just keep having this question, be like, you're setting up a new factory. Can we just not take all that piece of equipment you're buying, copy, put it somewhere here either on the West Coast or the East Coast, and maybe the West Coast because now Timber AP is doing their work, and turn up these engines? It's like, why are we just not doing this stuff? That's the frustrating part.
I feel like
but it's coming.
I thought I was hearing that like 4 years ago, and is it financing that makes it so slow, or is it just the physical construction and equipment?
Well, I'll kind of get the people at Timber HP will get mad at me, but here in Canada, the way I'm trying to get a wood factory up here, so I have these conversations like every month. We almost had one in Saskatchewan pre-COVID, but what Peter Moonen from the Canadian Wood Council tells me is you need 4 things: knowledge, willpower, wood supply, and $100 million. And typically you only need half that because the Canadian government will give you the other half because they want this too. So it's you need those 4 and you make this happening, and I'm almost there. So it's coming. And the more we have, the more competition, the more we need it. We're looking at this outboard insulation. It's a market. So we all need more insulation.
Is it the 100 million? Is that because of equipment?
It's a rough number to just get people to realize it's not like a $1 or $2 million thing. And realistically, when you're talking to investors, when you get over the $10 million mark, you're literally talking to about 30 people in Canada, and you're asking one of those 30 to just get on board. And so those are the fun conversations that I'm having, is which one of those 30 are going to jump on board. And I've talked to 2 out of 30, so I got a long way to go.
Well, it's always this chicken egg problem, right? Like the demand's not there.
The demand is there. Demand's there.
I think it is on all these things if it were around. We'll see with Glavel, right? I don't know.
Well, the thing is too, is other people that are competing already know, like, I have these conversations, and sorry to take away, Alan, I'll let you chime in here. I just get excited about this stuff because I want this. We all want this. We need it to happen. But again, Glavel is going to be a great change maker, because we've been waiting for this product for so long, and the foam industry has been like, oh, it's coming. And now when it comes, people are going to switch quickly, and then they're going to get into demand issues. But I've talked to Rob. He's ready to set up a factory on the West Coast and somewhere in the middle. And like same thing too. It's going to be like, Rob, what's the cost to just copy and paste your factory? And then it's same thing too, is where we're going to get all this recycled glass from. Well, we're all recycling. Glass is there.
Oh, it's going in landfills right now.
Yeah.
Single stream in the US, there's no market.
Yeah.
And honestly, it takes more to recycle it energy wise than it does to grind it up and put it in concrete or use it some other way. So.
And again, Glavel is still, a carbon intensive process, but the way Rob has done, where, once you start making money, he can put solar panels on his roof. He's got an electric furnace.
He's got it. It's now, I just saw him yesterday, actually. It's his process is going to be carbon free. Now that's because his energy mix has some nuclear in it. You can't say, totally renewable, but he's moving that in that direction. It's going to be totally renewable in like a year or so.
Yeah.
So it's like a carbon free product, which is amazing.
So again, if we keep pushing, people realize, hey, this is happening. But we're doing amazing work. I just keep thinking what's happened in 10 years with this Pasos community, and even the last 2 years, like the momentum that we're all working towards. We're pushing barriers and we're getting people to notice, hey, like things need to change. I just think of the carbon discussion, Chris Magwood, I kind of heard about him 3 years ago. Now he's on every show every week talking about what he's doing, and we're now all talking about it. Every time we do a Paso, it's like, oh, do we do foam or do we do something better, right? And any of the foam producers that are watching tonight, again, you're a great option right now.
Well, I just worry about us pushing things that aren't there right now, because then when people go look, they find it super expensive, and then they don't think about it when it's better price 5 or 10 years later, right? So like now that Glavel's here, we got to market the craziness out of that, right? But maybe wait on other
and Bev, the best thing about this right now is I kind of like to go back to the whole Tesla model, is the Tesla Roadster. People that want it can afford it, and they'll help drive it. That puts more money into the manufacturer's hands to then reinvest it. Then they'll scale up, and then they'll be able to offer the Tesla Model 3 model, and we're off to the races. So, as much as quickly what Tesla's done, we can do that too with some of these other products. And, within 8 to 10 years, we'll be doing these passive house Model 3, and we're already doing it now. We just need to do more of them. So, like with all the affordable homes in Philadelphia, and the things that Edie's going to do in Santa Fe, we just need to promote all this hard work and make sure that everyone gets the right kudos and say, look, they did in Santa Fe, they did in Philly. We can have sorry, Bev, I forgot about your all the amazing work you've done in your neighborhood. Like, we have all these great examples. Just let's do it everywhere. Copy and paste.
Which is why everyone should come to Passive House Network Conference in June, because it's in Boston and there's so much. Monty was telling me I have to set up no diesel buses. We just have to rent Blue Bites for everyone so that they can go around to everywhere, because we have so much to see.
So again, Bev, I know I put it on the calendar, but for everyone else, when are we all I say everyone coming to Boston?
I don't know. It's June. I don't even know.
Oh shoot, I know it's June too. Sorry, I didn't mean to put you on the spot. I know. I've got my I got my train. So everyone wants to join me. I'm gonna take a train. I'm gonna train to Boston, and then go across the U.S. and rowdy up everyone. And we're gonna have a big party on our way to Boston. So make a note of
There
that.
should be a New York train coming to Boston that like you just take over 4 cars.
Yeah. So sorry, Peter Molnar, you had a question, Mr. PH himself. Sorry, you had your hand up and I got on the soapbox tonight. Again, I just love this stuff too much. Alan's doing great work. So go ahead, Peter.
It's good to listen to you promote it. It's very good. Yeah, it's worthwhile. For Alan, just wondering if you were talking about early in the presentation, the amount of cutting you do and what lengths you have off of your takeoffs, using pivot tables and gather up all the data for cutting similar lengths and then assembling them.
Sorry, what's the question?
If you use from the spreadsheet you have from your cutting takeoffs.
Yep.
That using pivot tables and gathering up the data of how many similar units you need to cut. And so mass produce it.
Yeah, the software does it for
does that. Yes, it does that. Yep. And we do have like we have a Tiger Stop automated fence, so we can plug in all the dimensions and it moves the fence. You're not using a tape measure. And that's pretty effective.
And Alan, so that's the second piece of equipment I tell everyone to buy is the Tiger Stop on your shop saw.
Yeah. All right. Cool.
So this is why I love what you're doing, Alan. I'm like, you're already going down the right path. Peter, you'll appreciate this. One of the most automated factories in Canada is ACQ built it started as Landmark Homes. They bought 2 Weinman lines. They had it paid off in 6 months because, I mean, they're also doing 200 houses in the Edmonton area. They paid off those pieces of equipment in 6 months because of all the theft, waste, and, firewood that it created. So, again, it's a little bit of the scale. You jump from 1 or, maybe 10 houses in a shop, then you're into 20 with some automation, but then you go, 20, 40, 100 to 1,000. For those that missed it, there's a prefab conference or symposium here in Vancouver last Thursday with some major players, and our good friend Jerry McConaughey from Integra from down in California. He's got, a great machine running. But I keep bugging him, like, when are you going to put membranes and insulation on it like you did in Ireland? And he's like, yeah, the demand's not there. So, so again, it's how do you have these shops that can add those layers effectively and also be able to have different wall thicknesses for different climate zones? And that's part of the issues that Alan's dealing with is, which wall system do you do, or do you just have one system that is enough to get you through most of them, and then you jump to a thicker one that gets you to the rest? And I know a few prefab companies that are, looking at those 2 kind of options. So,
but the way to go is if you're building tract housing and similar sizing, then as you're doing, setting up a portable unit in the neighborhood, so as your shipping cost would reduce, you're talking about that. And then portable factories, and then move it somewhere else to the next tract.
Somebody asked earlier about what size facility you need to start panelizing, and I've been talking to this guy in Australia who literally set up a panel shop in his garage.
Yeah,
and he did modular panels like the public is doing, and it was like a 20-foot by 20-foot space, and he could crank out panels from there all day. So you don't need to be highly mechanized, and it's absolutely true that there should be, and this is true in Sweden and Germany, there's a house manufacturer in your town, and that's where the houses come from. And it doesn't have to come from these centralized mega factories. Like, hopefully it doesn't go that way, and it can still be a regional or regional supplier. And then you're, like you're saying, reducing your transportation costs and employing more people and using local resources and all that good stuff. So hopefully it goes that way.
Yeah, I mean, what's nice too about Europe is they've been doing it for so long. Like my favorite, and sorry, Gina, I see your hand up, I'll get to you in a second, is a company called Belfast. It's an hour and a half west of Munich, doing prefab for 35 years, been in business for 122, right? Like all the answers we're looking for, like we're not having to remake the wheel here. Copy and paste, make these connections, collaborate with them, and figure out how to, work with it so you can scale these things up faster. These answers are there, and I know other people have different favorites. Renglay in Switzerland's another beautiful one, and so Gene, over to you.
I might have missed it, but is there anything in any insulation in the stud cavities? And what about mineral wool as a replacement for the wood fiber?
Great questions. We do not ship the panels with any insulation in the stud cavities because that's open for electrical and mechanical, right? We could do that, and some people do that, and then you have to have an additional service cavity, another wall on the inside. I actually think it's more efficient to just have that stud wall be open and have the mechanical electrical go in there, and then local GC, or if we're the GC, we'll just get the cellulose company to come in and net the walls and then fill them with cellulose. Mineral wool, we did use that for a while. We used the rigid mineral wool on the exterior, and my crew just hated working with it. I don't know if there are any manufacturers here. I'm sorry to say, it's just so itchy and nasty and dusty that I had a mutiny on my hands. Plus, it's gotten really expensive, and it's not as rigid as the wood fiber, so you have to take a lot more care in planing out your exterior strapping. It just has, I mean, it's great because it's fireproof and waterproof and all that good stuff. I like it for that reason, but workability is not great. And it's not, I mean, it's really high embodied energy to produce it too. You're turning a rock into this fluffy cotton candy, and it takes a lot of heat and pressure to do that.
Yeah, I just threw in a really good link called Materials Palette, and looks at the carbon footprint of different installation options, Gene, so you can look at that, for options. As Chris Magwood says, if it's made from Mother Nature, it's going to store carbon. There's your option. There's lots to choose from. We just need to scale those, materials up, but now that, again, just a segue too, there's going to be a lot of hemp on the marketplace now that we've approved it for other needs. A lot of fiber there to be used. So there's a nice factory started in Quebec that's producing stuff down and supplying the East Coast. So it's coming. Jeff, you had a great question about pre-drilling.
Yeah, so Alan, having an open service cavity makes a lot of sense. Do you do any work in your factory to sort of help the electricians and the plumbers, like pre-drilling studs for pulling wires and plumbing? And
no, we don't. I mean, that's a good idea. I wouldn't begin to try to figure out what the plumber's going to do, but the electrician's a little more predictable. So yeah, you could do that.
Having every stud with a hole at 2 feet above, floor is pretty much all you need for electric.
Yeah, that's a good idea. I mean, I think if we had some sort of automated saw that could just punch those holes in real easily, that would make sense. I'm not sure. I don't know. Yeah, I don't know how we'd price that. Like, are we gonna be able to say that our panels are better because the electrician is happier and doesn't have as much work? Maybe. Yeah.
Again, it's one of those service things that if you can figure out with the GC, like, oh, I'm just going to take, all the drilling I'm going to do so that no one punctures the air barrier, we'll do it here, and we'll give you the pathways. Or, and again, Mark's here, got to give him a shout out.
You could even
T-stud, there's already that hole's already drilled.
T-stud, yeah, there you go.
So you could even investigate pulling the wire.
Yeah, like it's tricky when you're doing out-of-state stuff, but
it gets tricky, and the connections.
Yeah, you need to have an electrician to understand it and stuff like that. Yeah, but these are all things that you pre-think it, and it's standard. I'm sorry. Last
Jeff,
time I looked, the wire that was pulled in my house is all the same.
Jeff, it's really good too is when you're in the floor cassettes, if you can pre-install like the longest piece of pipe for the plumbers will appreciate it, because a lot of times if they've got to just put 4-foot connections all the way through because they couldn't get into the studs, it's nice to have, the long pipe, because you're like, oh, one solid pipe, less connections, less leaks. So those things can help out.
Yeah. People like Holtram they take that whole 3D model to a next level by putting all the mechanicals into it. So you can see where everything's going to be. And then, yeah, there's a lot better opportunity for doing some of that in the panels. I mean, I love the idea of the mechanical clamp on system. You know, some people are developing that, or the modular kitchen that drops in. You know, there are ways to make Panelized take some of the advantage of modular and do components that sort of bolt on, which is exciting. And I've seen some of that in Europe.
I actually have one last question, which is more at the business level, which is, and it's focused more on the developer, I think, is that how much faster is your prefabricated component construction than traditional panelization and stick built? Because towns and communities, I think, would react very favorably if you told them that your disruption to community is only going to last, you know, half as long, or, you know, 25% as long. I mean, that's something of value to the community.
Yeah, what I'd say is the overall time frame may not be shorter, but the time on site is significantly shorter. So
but that's what they care about. But that's
exactly,
what communities care about, right?
Exactly. So we can reduce the entire shell. Like what I just showed in my slides was 10 days of work on site, right? As opposed to a conventional, you know, 2 months maybe, or more, 3 months, and it's all getting wet and snowed on and iced over in that time.
Well, so, when you're talking about building these multifamilies in urban areas, community disruption is a huge cost, and it includes everything from police details to just plain, you know, noise.
Sure. Oh yeah, significantly, I think is the answer.
Jeff, you brought up a great point. There's, you know, again, there's a lot of value in prefab. The biggest thing that I get frustrated with was people like, oh, prefab should be cheaper. No, prefab is not cheaper. Prefab provides you a higher level of quality. And I mean, to where it's not cheaper, but it saves the developer money because they're looking at their finance cost of not having somebody, you know, in that. So the developer makes money for the faster thing, but you're also, again, overlapping trades. So while you're pouring the concrete, they're building everything in the shop. So you're speeding up the construction process. You're providing a lot more value, and a lot of things you just said make it ideal. The one thing that I have to point out, because there's a lot of craftspeople in the show, is that you know, we have an issue before we even talk about passive house. We have an issue with skilled workforce, and so the prefab aspect is helping out because we don't have enough trades to build what we need to do. And, you know, we haven't even talked about the retrofits, right? I mean, the number that Alan said to us is they need 90,000 houses to be retrofitted. Alan, is that the number? Anyhow, it's like 100 factories, and you can have 90 factories just working on retrofit panels. So, you know, we need to get over some of these things and make sure that we're still applying the craft and the love we have for homes. It just needs to look a little different because we can't build them the way we used to. We don't have the same people power, human power. We need to do things differently. So just gotta keep the craft of our homes alive.
From a building perspective, the craft model works great when you have low cost, plentiful labor.
We don't have it anymore.
That exactly.
And if we do bring it in,
it's never ever going to come back at the scale that we need. Right.
And Jeff, I'll say, like, your electricians comment, like, there are not going to be enough electricians at all. Like, if we get to net zero by 2050, we need 3 times as many electricians as we have now. You're not going to want them to be running those, you know, we do have to find ways to do this easier so that those electricians are doing the things we need to for all the other parts of our economy that have to be electrified.
Oh, we also have to switch over to low voltage DC wiring for as much as we can and save all that copper and all those boxes and all those fixtures, and that's coming.
We talked about that last night, Alan, on our solar show. Is if we got all these solar panels, all the lights should be DC, and so yeah, that was we had a good discussion about that last night.
Cool.
So where is our lumen guy? Lumen
No,
guy?
we got a Derek he's somewhere in China. We'll get him back soon enough. But yeah, we
Come
gave
on,
him a big
Derek.
promo
Right
last
when
night
you
too.
could have plugged his lumen cache, he's not here. So I'll do it for him.
Yeah, well, good on you. We need to keep doing it. Sorry, Gene, you got your hand up again. Thanks for keeping the peace.
Would using T studs or some kind of engineered stud with cavities provide the electrical and mechanical space, and also would it be an advantage for lighter weight for handling the panels?
Mark, I'm not even going to ask the question. I'm just going to turn over to you. We're so late in the show. You can ask and promote your product. Give us the goods, my friend.
Well, the panels that Alan have are, superb panels, but the weight aspect doesn't differ because in order to get the engineering strength, we use two 2x3s to produce a 2x6 or two 2x4s to produce a 2x8. So the weight and fiber amount is actually the same. It's just the fiber is separated to create either 1.5 inches or a 2 1/4 thermal break. And to that effect, also, June, we've seen many folks use it on the wet walls, right, or the core of the house, because the PEX and the systems that run there for the bath are used, as well as the sound attenuation that happens. The thermal properties often behave like a sound property. It's really unique in that manner, but the weight is the same. I wouldn't worry about the weight. The dexterity of the panels that Alan makes and the folks in his industry, the weight is not the focus, it's the performance for sure, right?
Mark, can I ask a question? With the increase,
how about well, Jeff, how about we do the email, because this is not right. We'll
no,
just do that one
but I
second.
think this would be interesting for everybody.
Okay.
Because
Yeah, Sean.
with the
Go ahead, and then we'll go back to Gene.
With the
Hi,
increased strength of the T-stud, the compressive strength, you can do 24 on center on your first floors or your lower floors, because
depending on your size, just like passive house and climate related, depending on your seismic and snow load, the formulation of the wall panel may not be able to accommodate the 24. In many cases, it can, Jeff. And also your cladding option. Unfortunately, a lot of the cladding options require the nailing pattern. So as much as I know exactly where your head is, as much as the engineering is out there, especially from these offsite folks that we're blessed to hear about tonight, some of the products that get added to it don't have the mechanisms to achieve that kind of advanced engineering.
Thank you.
All right, Gene, back to you, and then Hans is back. So love it when we stay so late, people pick up their kids and come back. But Gene, over to you.
I'm done. Thank you.
You're good? Okay. Hans, thanks for coming back.
Yeah. In the car while I was driving, I was thinking about this window thing. And I'm like, actually, a much more interesting question is whether or not you were able to eliminate the typical air leaks around the windows with pre-installing them in the buck.
We've had really good results. Yeah, we can make a really nice airtight assembly in those bucks. And I mean, I wouldn't say, the way we used to do it was install the windows flush with the OSB sheathing layer and tape them right in. That's a good system too. It just had some other challenges in terms of how you build outboard of that. But I like the buck system. You have to, you have to air seal the buck, the joints in the bucks at the corners you have to air seal, and then you have to air seal the buck itself to your sheathing layer or whatever your airtight layer is. And then you have to seal the window into the buck. So it might be another step, but it has a lot of advantages in the prefab assembly, I think, especially doing the pre-assemblies of the windows.
I presume long-term as well for the window, for the durability.
Yeah, I think the way we did it previously was pretty robust, but I think this way is better. Yep.
Cool. That's awesome. Thanks.
Sure.
Well, I'm just going to give a shout out to Rain, and because we've got a legend, we have the prefab legend joining us tonight, folks. Yes, giving him a shout out. I know they worked hard today. They're, are you guys in Washington State today, or where are you guys? Thanks for staying on late, Rain. You've already put in like probably 12 hours on site, and now you're, relaxing with us.
Of course, love to see all your nice faces. We're in Grayland, Washington, right on the coast. So wet but beautiful.
So this is the first time you've been dry in 10 hours today. You've had a shower all day long.
Exactly. Yeah.
If you guys haven't, actually, I think Rain, your Instagram photos are lapped, but if anyone didn't see the last few days, literally torrential rain, nonstop putting in panels. So Rain has the best line. He's like, anybody can build panels. Once they get them in the air, then you become a prefab company. And today, I'm sure they were testing it, because again, you build these in a factory, millimeter precision. You get them on site, you need to land them in millimeter precision, and it takes a prefab legend and Rain to be able to do it.
That's why we bring the legend to all these.
All right, everybody, we're at the top of 2 hours. We have stolen too much of Alan's life, and we've sucked him dry with all his knowledge. And the best part is he would keep going, but I'm going to shut him down because it's been a great night. Alan, thank you very much. Any final words for you, Alan?
This has been loads of fun. Thanks everyone for your questions. I really appreciate it. It's been great being here.
Yeah,
thanks. Keep up the good work.
And what's great too is everyone give him a big handshake. Is the best part too is anyone tries to create a factory like Alan, nobody will do it, because you will not know what he has created, and you'll never catch up to him because he's just on his own path. And luckily he's able to share and collaborate with all of us. It's great. Bev, any final words for you? Thanks again for being the host tonight, and look forward to having you on for the next few months.
Yeah, no, it was great, Alan. Thank you so much. What a great conversation.
Yes, it was. Thank you.